Yeah, so before we start, thank you very much, Software Mention, for inviting and hosting all of us. So that's been a great pleasure. So yeah, and today I'm gonna talk about CyanView and what we do. So I think we are a bit of a unique company because we build the hardware and software for the super niche market. So today we're gonna talk about from Super Bowl to Olympics and yeah, how CyanView does that. So a couple of words about me. So I've been doing the Elixir development for the past, I don't know, maybe around 5 years. So I'm working with CyanView primarily. So I still have some open source projects. Maybe you know me as a Phoenix Analytics, if anyone saw it on GitHub. And yeah, sometimes I do as well some help with the staffing and consulting for the Elixir. So what we're gonna cover today, so essentially how the small startup like us, I mean the small company, powering like the largest broadcast events. So what are the challenges? And of course, we're gonna talk about Elixir. And I try to highlight the most interesting parts, probably not very common ones. Yeah, we will go a bit in a deep dive. I'll show how we organize the code and as well, actually this year we started using LiveView straight on the devices. And yeah, we're gonna talk about a bit our future plans. So yeah, CyanView. It's a Belgium-based company founded by 3 people and 9 employees in 9 years, and that's it. So we have the linear growth of 1 employee per year, and we're trying to keep that. So we produce hardware and software. So there is a lot of terms which are probably not known to you, but I will try to make sense during the talk. So RCP, it's our, let's say, flagmanship. It's a remote control panel, and I'll show the photos later. We have as well the VP4 for the video processing, custom REMI relay server, and now we started building a lot of software on top of our devices to become even more flexible. So our solution is used on Super Bowl, Olympics, NBA, football matches, Amazon Prime, fashion shows, almost everywhere where you have the broadcast events. So one of the largest capability, it's 200 cameras controlled from a single device simultaneously, and it was during the Le Mans race. So we have 0 marketing. And when I put 0 marketing on a slide, our CEO, David, he came to me, he's like, no, please don't put 0 marketing. Some people claim that we have a website and it costs us money. So yeah, we do have a website. And originally the company started because back in the day, cameras were not designed for the internet use. So especially when you need to control the camera, it was not possible back in the day. So that's how the idea of the remote camera control and shading actually started. So this is our devices. So RCP, it's our flagman. So with it, you can control more than 190 cameras, which we support at the moment. So some of the cameras, as I mentioned in previous slide, were, let's say, old and do not support IP-first approach. You have CIO, which can convert the serial into IP. We have RIO, which helps to do the remote production and control cameras using 4G, 5G, IP to IP mesh, and I mean, the flexibility of setup just limited by your imagination. So we have as well the VP4, which is the color corrector for the cameras, which do not support the color shading and so on. And a few other ones, which we're not gonna cover today. So yeah, that's us. It was the last picnic. That's the entire team. We have, I think now around 10 full-time employees and 2 part-time. So before we jump into our famous Olympics Beijing case study, raise a hand if you ever watch a football match. All right, so almost everyone knows what I'm talking about. Have you saw that there is multiple angles which are filmed from different cameras, different models, different brands. And you're not gonna believe me, but most of them display the green color differently. And so once you see the picture on your screen, our job to make sure that you see the same green from all the cameras. It's called color shading. And during the Olympic Games in Beijing, so there was a challenge. So you have the production, the studio, which is filming, located in Beijing. And you have Panasonic PTZ cameras. PTZ cameras, the ones which you can control the angle. And the control team was sitting in Paris. So, and Panasonic not really designed to do the, control over the network. So it's only for the local use. So the solution was simple. So you plug the CyanView devices next to each camera. Through our custom REMI relay protocol, we're able to formate the cluster of MQTT and seamlessly connect it with the team in Paris. So we as well have a custom proprietary protocol which helps us to reduce latency. So as a result, we got the 0 broadcast failures during the Olympics. And this is crucial because you don't have not even a chance, but there is no way that you can fail. And so sub-second response rate and millions of MQTT events were processed. And why it's famous? Because I think the first time when it was published, we went #1 on Hacker News. That's how we ended up being a bit known in the Elixir community. So yeah, now let's move to the Elixir part. Here I try to outline some of the setups which we have. So if you would like, you can scan the QR code and you will have more expanded version. But yeah, so for the small specialty cameras, you can connect them via CIO and then connect it to our RCP unit and you will be able to control and shade them. Then you're able to get the cinematic cameras, connect the REVO, and as well connect to our RCP and control it like you want. And of course, the diagrams don't really make sense. So, and by nice chance, last week we were on IBC where we had all of those setups actually up and running and working at our stand. And I just discovered yesterday that I can do this. So yeah, here, for example, people are controlling from our RCP through the CIO, the small PTZ cams, small specialty cams. Here, for example, the red camera, which is connected to our Rio device and can be controlled from anywhere where the network is reachable. So here was one of our, let's say, latest integrations. So now you can control the lenses using the Seagate. So it's quite flexible. And that's our flagman. So this is the RCP with the Iris joystick. So essentially, yeah, the biggest toy we have. So why Elixir? So we have 190 plus models integrated and supported. We have multiple video routers, switchers, and video processors. One of that we develop on our own. So there is a lot of different protocols, starting from the TCP, UDP, and ending up with exotic like Ember Plus, and absolutely custom binary protocols. So that's our challenge, and we have to deal with it. So essentially, Elixir was the perfect choice for us, because obviously we don't have a chance to fail. So Elixir is known for the fault tolerance. And besides that, we're keeping all the processes alive and have a retry mechanisms. For us, it's critical as well to hold the C code in the process and as well bring this reliability to C code. So as you know as well, Elixir and Erlang has the great ability to coordinate million devices. So that's essentially what we need. So on a big event, it can be, I don't know, more than 200 cameras connected to multiple RCP units, and we need to control them flawlessly without any errors or mistakes. So with the help of MQTT, which is the lightweight message broker, we actually achieve that. I will talk as well a bit, so what's custom we added to the MQTT. Obviously, supervision trees, we use it everywhere, and a lot of recovery mechanisms. So sometimes camera can go offline, sometimes it can go back, and what's gonna happen if you send a command, so should we retry it, or it's already there. So there is a lot of unknown state, let's say, and we are dealing with this and recovering from that. So IP first approach in the Erlang and OTP itself, you have a lot of tooling which comes to the internet and IP. So this is like really greatest library probably to use. And another thing which is critical to us is the binary pattern matching. So I will stop on the next slide and explain why for us it's critical. So yeah, essentially, David was saying that the broadcast is a business where you only get one chance to prove that your tool is working. So the reliability is the king, 0 failures. And actually, we started with Elixir, I think, around 7 years ago. So by main developer, who was the first, Gillen. And he thought it's going to be a great idea because it's so versatile and covers all our use cases. And we started using the Elixir. So yeah, why binary pattern matching? Obviously, since we run it on a tiny devices, they have, I don't know, Ethernet power line, and that's it. So it's usually 2 or 4 ARM cores, and it's not gigabytes of data, like gigabytes of RAM like you have on your laptop. It's very small. So binary protocols used to communicate with a lot of hardware, and for us, what is critical, it's zero copy parsing, so that we don't have a lot of memory spikes and we don't copy paste anything into memory. So we just parse it directly, and in the Beam machine, actually pattern matching is compiled to much more efficient code, and it does it very fast. So in our code base, you will see a lot of things like that. So just a bit on the code organization, because when I joined, I mean, I knew that monoliths exist, but we have a next version of monolith, as I think. So we have a lot of internal apps, more than 40, and based on the device, we create the specific build where we put the different capabilities together, and then we compile it and put it on the device. So essentially, once you need to update your device, we create the new binary, upload it on our website, and anyone who wants to update, they pick the latest version, upload it on their device, and in 5 minutes they have latest firmware. So another, let's say, use case in our industry, if something stopped working, because, I don't know, camera changed the protocol or anything, you're always able to put the previous version back and proceed as it was before. So yeah, custom MQTT. We had to design in a way how we're going to communicate between all our devices and components. So one of the features which we have, so the last value set for the camera or the video processing board, so once client subscribes, you get all this data back so that you can get the latest state which is now held on the device. So this is how we solve the issue of like some maybe race conditions and dirty reads and dirty writes. So yeah, this year we started using Phoenix LiveView on our embedded devices. So one of the first thing which we had to do, we have a color corrector box. If someone is interested, yeah, put some QR codes with the video, how it works. So essentially from MQTT, it goes to Elixir, and then in Phoenix, I had to implement a batching mechanism so that we do not re-render everything at once, and then it goes to the LiveView, and this is raw SVG plus JS hooks. 0 libraries used, nothing. So on the device, it was running quite well. It was much more responsive than our previous app. So, and here on 2 ARM cores, you can process, I think, approximately 300 events per second, LiveView events. So as well, what we use on that device, it's a 3D LUT computation. So we gather all the parameters from the LiveView, which goes into embedded Acto schema. and then 3D LUT is computed via C code. So that's one of the use cases which we have on the devices right now. So currently as well, we were presenting at IBC the dashboard. So we bring even more flexibility to our setup. It's as well LiveView, and as you can see, Daisy UI. You will be able to control absolutely any device which we currently have from the embedded device. So which means that you might plug just the Rio device next to the cameras and have a laptop in your production, and that's it. So you we bring that flexibility as well. So I was able to optimize the LiveView rendering to 2,000 events per second. So you can get all the data, all the details from your cameras, colors, gains, white balance, absolutely everything in the real time. And I was actually surprised how it was easy to make the side panel, which is an iframe, but I as well use it on the mobile view. So the great reuse of the resources. So yeah, a bit about our future developments. So we go more and more towards the remote production, which Elixir allows us to convert from devices and go more into the cloud. So we're preparing as well now the cloud dashboard, so you can control all your cameras from the cloud solution. We work on the new OpenGear 4K FPGA, so the small color box I was showing you before. Now we are working on the new device, which will be bigger, greater, faster, and of course we will use the Elixir and Elixir LiveView to build a color correcting app on top of that. So one of the things which I was actually working this summer to build a prototype of using membrane on the device to have the small vignette preview of the stream. So once you have a picture from the camera, and if you need just to do the color correction, you don't need 60 frames per second. It can be 5, 10 frames. And yeah, that's still work in progress. So maybe one day we will have a membrane running on our devices as well. So I think that's it from me. I hope you learned something new. And yeah, it was CyanView.
Question times. Does anyone have any questions? Please raise your hand. There is one question over there.
Yes, I was a bit interested about the color shading. Do you have presets for different cameras, or do you go by camera?
You go camera by camera, but now in the dashboard application, you will have some presets which are allowing you to, let's say, apply this, and it's gonna spawn all the events on the MQTT, and camera will be, controlled from the template.
And do you have like some color grading table that you use for that, or just go by, let's say, just grass?
It only depends on the cameras. So essentially, for example, the famous thing which is called ISO, right? And on cameras you have ISO, but on one camera ISO 5000 can mean absolutely different that 5000 ISO on another camera. So it's quite a lot of manual work for the directors and operators.
Thank you.
I do believe that there were questions over here.
Thank you for the presentation. I was wondering if you use nerves to build the firmware.
Actually, no, we're using Yocto. I don't know why the decision was not to use nerves. I think they were missing something back in the day because, we started 7 years ago, and Yocto was the way to go for us.
Okay, and I have a second question, if I may. I was wondering which protocol do you use to transfer the video and audio from this, like your embedded device to the internet? For example, when you had the Beijing Games, and then you said you were sending data to Paris.
Yeah, that's the thing. We do not deal with the video or audio streams. That we leave to you. And what we do the camera control and shading specifically. So we do not touch the video signal, only in our VP4 boxes, where we apply the 3D LUT for the SDI conversion.
Okay, thanks.
I think that we might have time for one more question. The gentleman over there.
How do you do rolling updates and auto updates on your devices?
We don't.
Okay.
It's a manual update, because usually in the industry, so the life cycle of the setup, so it's like 5 or 6 years. So you purchase amount of cameras, lenses, controls, and etc. You set up it once, and you try not to touch it or upgrade it.
And what happens if your customer finds a bug?
Usually we quite prompt on the support, so we have a support email, and the whole team usually receives it. And yeah, we're trying to be as fast as possible.
Okay, thank you.
All right, unless there are any more questions, there is one more. Very nice.
Hey, thank you for the presentation. I was just curious, how can you produce hardware with such a small team? Do you just like prototype it in the office and then you use third-party companies to actually make it?
Yeah, that's exact approach. So once you come to our office, it's how to say, it's an organized chaos of all possible tools, PCB boards, etc. So we do the PCB design in-house, and then obviously we have a lot of testing in-house, how to wire it together, and then we have the third-party production, which is actually producing the end product.
And how many people deal with the electronics versus how many deal with software? Just more or less, like.
I would say 1.5 is doing the hardware part, same half, and another 2 doing the software part.
Perfect, thanks.
All right. Thank you again, Daniil.
Thank you very much.